All right. Nine point two, which is confidence intervals for a sample mean. Okay? So just like last time, it's basically the form is going to be your point estimate plus or minus your margin of error. Okay? So just want to make sure we're all clear. What is a point estimate for a mean in this case? What letter do I use for that? What? Mu? No, mu's for population. X bar. Okay? Your point estimate for this one is going to be X bar. It's not going to be P hat. P hat signifies it's a proportion. X bar signifies it's a mean. Okay? So, and then I'm going to do plus or minus your margin of error. I'm not going to, well, so when you're figuring out your margin of error, there's a question you need to ask yourself. Okay? Do I know the population standard deviation? Okay? There's only two answers to that, correct? One is yes, I do, and the other answer is no, I don't. Okay? If the answer is yes, I do, I'm going to use the Z distribution. If the answer is no, I don't, I'm going to use the T distribution. Okay? You guys haven't heard of the T distribution until today, right? Okay, so let's talk about it's called the student T distribution. Okay? It was discovered by a guy by the name of William Gossett. Okay, he actually worked for a beer company. Okay, so if you thought nothing ever good came from beer, we got the T distribution. Okay, so it's used when you don't know the population standard deviation, which is a lot. We usually don't know it, so we use it a lot. Okay, so the equation for the T distribution, you may look at this and you say, gosh, that looks really familiar. Okay? The equation is going to be X bar minus mu over S over the square root of n. What does that look suspiciously like? Looks like a z-score. What's the main difference? Okay? Well, it's T there, but the main difference is I'm using your sample standard deviation as opposed to your population standard deviation. Okay? Now, one of the other things about the T distribution is it has with degrees of freedom. Okay, your degrees of freedom equals n minus 1. Okay? That's just what they call it. Okay, so let's talk about properties of the T distribution. Okay? Before I do that, just let me show you something really quickly. Actually, let me do this. You're all familiar with the normal distribution, or what we call the Z distribution, or something like that. Okay? If I were to draw a T distribution, it would look something like that. Okay? That's your T distribution. Notice it looks very similar to your Z distribution, but it's got bigger tails. Okay? So, number one, the shape of the T distribution changes based on your degrees of freedom. And what are your degrees of freedom based on? You got your tripod today, huh? I did. The degrees of freedom are based on your sample size. Okay? Number 2, the t-distribution is centered at 0 and symmetric about 0. Okay, so kind of like your standard normal. It's going to be just like that. I'll let you know this third property, the area under the curve. What do you think that equals? Equals 1, 4 as t increases at each end. The graph approaches 0. And number 5, the area in the tails is larger than the z distribution. And the reason why the area is larger is because we're using the sample deviation as opposed to the population deviation. Okay? Finally, number 6, as your and increases, the shape looks more like the z distribution. And in fact, when your n gets really big, they're almost indistinguishable. To the right is 0.10 with 15 degrees of freedom. Okay? So as we're looking at our table here, and now by the way, let me just mention here really quickly, if I pull back to the normal distribution, if I look at the picture there, it gives me the area to the left. Okay? However, on the t-distribution, it gives me the area to the right. So just make sure you're paying attention to that. Okay, so area to the right of the tail, we want 10%. So I'm in this column here. I want 15 degrees of freedom. So if I go down here, 15 degrees of freedom, 10, I get the value 1.341 there. Does that make sense? Okay, so this table works a little bit differently than the other one. All right, so let's do an example. Oh, now by the way, the one thing that I want to mention here, the reason why I left that margin of error as kind of vague yet. Okay, so we've got 2 formulas here. And remember, this is the key question, okay? The formulas are very similar. In one case, it's going to be, in the yes case, it's going to be x bar plus or minus z sub alpha over 2 times sigma over the square root of n, okay? In the no case, it's going to be x bar plus or minus t sub alpha over 2 times s over the square root of n. So you can see those formulas are very similar, and it all depends. Do I know? Now you guys are familiar with the z, so I'd like to concentrate on the t this time. And if we have time, I'll do a z. Okay? So let's do an example here. Okay, an arborist wants to determine the mean diameter of mature white oak trees. The data below represents trees 1 meter above the base. Treat as simple random sample and construct a 95% confidence interval. Okay? So I've got some raw data here. Went out and measured it myself. 6, 1.5, 9.2, and got some raw data here. What is the first thing you probably think would be a useful thing to figure out? You'd like to figure out your mean or x bar. Mean x bar. Okay, how do I find my x bar? Average of the Curse Bill Gates. Okay? All right, what next?
Stop.
Okay, so the question is, do I know the population standard deviation? No, I do not. So which one am I using? T-distribution. Okay, according to T-distribution, I'm going to need to know my T. My T sub alpha over 2. I'm going to need to know my S. What's S? Standard deviation. I'm going to need to know my N. And in order to do the T, what else do I need to know? Degrees of freedom, right? Okay. And hopefully that'll give me my critical value. Okay? Alright, so standard deviation, I can figure that one out, right? What's the easy way to find the standard deviation? Taylor knows, right? Which one do I use?
Huh?
Which one of those do I use?
The one you're on.
No, the one I'm on is wrong.
That one with S.
STD, this is the one, the dot S is okay, this is the one I prefer, but the dot S is also okay. Okay, because it's a sample, right? What's my N? 7, so my degrees of freedom is 6. I need to find my critical value. Now let's think about this for a second, okay? I've got my T-distribution. If I want a 95% confidence interval, what should be in my tails? I want 0.025 or 2.5%, right? So I want 0.025. Okay, so what column am I looking at on my table? I'm looking at the 5% column? No, I'm looking at the 2.5% column. Okay? So my degrees of freedom, oh, I guess that's the same. The T sub alpha over 2 is my critical value. Same thing. Okay, so I'm looking at 6 degrees of freedom and I'm looking at 2.5%. Okay, so when I go over here, 6 degrees of freedom, 2.5% is 2.447. Does that make sense? Okay? All right. 2.447. Okay? So now I'm going to do a lower and an upper. Okay. In this case, I'm going to take my mean. I'm going to subtract the critical value. I'm going to multiply that times the standard deviation. I'm going to divide by the square root of my sample size. Okay? That make sense? Okay, now if I want to copy it, don't copy it here, copy it up here. If I copy that and paste it, I should get the exact same answer. Now I change that minus to a plus. And then Clara, I know, wanted to give me an interpretation of that confidence interval. Just do it.
95% confidence with the diameter of the mature rate of freezes between 32
Centimeters and
6.
4 centimeters. Okay? You got any questions on interpretation, Clara's who you can talk to. Oh, very good. Okay? Does that make sense? All right. So, cool. You want to do another one? Megan does, I can tell. Tell by the look on her face. She's like, this looks like fun. Okay? All right, how about Okay, here we'll do another one. Residents are concerned about speed limit. We want to estimate the population mean speed of cars on a highway with a speed limit of 45 miles per hour. They track 12 cars and find X bar equals 9.62. Highway patrol tells them the population standard deviation is 6.2 miles per hour. Creates a 90% confidence interval. Are the residents correct that speed is a problem? Okay. So, Ryan, I think it's your turn. So I didn't give you raw data this time, I just gave you summary data. So what should be the first question if you're creating a 90% confidence interval?
You want to find the z's of alpha.
Why did you pick Z?
So we gotta pick z because it's given us the standard deviation.
Yes. Do you know the population standard deviation? Yes. So we're going to use the Z. Okay? So I gave you the X bar in this case was 59.62. What else did I tell you? Population with sigma is 6.2 miles per hour. And anything else on them? M equals 12. Okay? So, let's see, I've got my X bar, I got my sigma, I got my M. What am I missing? I need my Z sub alpha, the critical value, which is Z sub alpha. How do I find my critical value? Look at the chart. 90% confidence interval, my critical value is 1.645. We need a lower, and we need an upper. So Ryan, how do I do this?
Do the x bar,
Which is?
9.62
9.62 minus
your z, the critical value,
times
divided by the sigma divided by
square root of n. Okay, so I got 56.62, change that to a plus. Okay, so Taylor was going to interpret that for me.
We are at 62%. We are.
It's really precise, 62% confident.
Some percent confident.
Yeah, what percent confident are we?
90% confident.
We're 90%
We're
confident
90% confident that the value is between 56 point.
Value.
No.
What value? No, the value.
Oh, the value.
Of
the speed of the
the
cars.
speed of the cars.
The speed of the cars is between 56.6 miles per hour and 62.5 miles per hour.
Okay, so are the residents correct that speed is a problem?
Speed is a problem because it's 45 miles per hour speed
Yeah.
limit.
It's 45 and we're well outside of that.
It's like Center Street
We're
North.
90% sure, okay? All right, so I've never been in a neighborhood where residents got all up in arms until my current neighborhood. The speed limit's 25, and I actually called the police and said, we think people are speeding. And they actually put up both a visible sign that said your speed is, as well as the one that they just track people without telling them. And the average speed was like 20. And they were like, there was one time somebody went 33. So anyway, sometimes people can do it. Okay, so quiz tomorrow, 9.2.